All right, 6-5, operations with radical expressions. Tomorrow's lesson's easier than today. This one's a little bit challenging. 20, 25 minutes. All right, let's start off with simplifying radicals. Simplifying radicals. Example 1, letter A. That's an A, not a 9. Square root of 75x cubed. So my index is the number that's in the little area of the square root of the little radical. This one, there isn't one, so it's 2. So this is a square root, so we need 2's. We need twins to get out of jail. I personally would probably do 3 and 25. And then 5 and 5. Does the 5 have a twin?
Yeah.
So it gets out. Does the 3 have a twin?
Yes.
Nope, so it goes to the radical. We have 3 x's here. 1, 2, 3. In order to get out, we need 2. So one set gets out, one set does not get out. So my final answer is going to be 5x square root 3x.
Wait, why don't we do... Never mind. Never mind. I'm going to
Yes.
question everybody answer it.
All right. Try this one with your group. Since it's Colin said it's easy.
Oh, Colin, you're so smart.
It's a cube root, so instead of looking for twins, we're looking for triplets. I'll give you a hint that goes into 216. 3 and 72. I'm sure you all knew that off the top of your heads. All right, go from there, please.
What? For the x to the power of 5.
I'll get that.
It looks like this. You're welcome to look. Do you multiply the 2 boxes?
I'm sorry, what? No, I'm sorry. All right, let's go ahead and try and solve this. What goes into 72? 3 and 24, I like that better. What goes into 24? What goes into 8? What goes into 4? You're not wrong, Liam. There's several different ways we could do this. I just did this like this on purpose because if you look, we need how many to get out of the radical? How many do I have there? How many do I have there? 1, 2, 3. So when they get out, they multiply. 2 times 3 is 6. So the 6 got out. And now let's try and figure out what's going on. I didn't leave myself much room there. That wasn't very smart. 1, 2, 3, 4, 5. How many does it take to get out? So that set right there gets out. So we're going to squeeze an X in right there. These 2 did not get out. They're bad. There you go.
Wait, so what goes in the box? Oh, double. Did I confuse you?
No, you made my head hurt.
Sorry.
It's all right. All right, continuing on. All right, what are you confused on, JoJo? Okay. What we did is we broke this down as much as we could. 3 and 72 is 216. 3 and 24 is 72. 3 and 8 is 24. 2 and 4 is 8, and 2 and 2 is 4. In order to get out, since there's a 3 right here, we're looking for the cube root. So you need triplets to get out. So I have 1, 2, 3. So the 3's got out. I have 1, 2, 3, so the 2's got out. What's 3 times 2? So I have 5 x's, right? 1, 2, 3, 4, 5. How many does it take to get out? 3. So these 3 got out as 1. One set of triplets got out. These 2 did not get out, so they're still in the radical. Are you sure? All right. This is less confusing than those lacrosse rules.
Oh.
All right. We are a third of the way done with our lesson. You're not going to like this part. I'm just saying. Multiply and divide. Because in order to multiply or divide radicals, we must, yes, I'm yelling, must have the same index. And remember, index is the number in front of the square root, cube root, fourth root, fifth root, yada, yada, yada. All right, let's try this. This is example 2, letter A. We have the fifth root. So we're looking for, I don't even know what 5 is, quintuplets? Is that 5?
Yeah. Yeah.
All right, the fifth root of 16x cubed. Yes, example 2, letter A. 16x cubed times the fifth root, 8x to the fourth. So first thing, do we have the same root? They're both 5s, right? So that makes life a lot easier for us because we can just multiply straight across. The index is the root. So we know it's going to be the fifth root. 16 times 8 is 128. Now we're multiplying, so when you multiply exponents with the same base, you just add the exponents. So 3 plus 4 is x to the 7th. Let's break down 128, 2, and 64. We're just going to use 2's for all of these. 2 and 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. All right, how many does it take to get out?
5.
So let's see. 1, 2, 3, 4, 5. They get out. That's fine. Oh, man. All right, I'm sorry, what? It doesn't matter. All right, so who got out? One set of 2's got out, correct? Let's look at our x's. We have 1, 2, 3, 4, 5, 6, 7. In order to get out, you need 5. So one group of x's got out. All right, so now this is our fifth root. Who did not get out? Those 2's. So 2 times 2 is 4, and x times x is, there you go. Congratulations. That's the easy part of this one. All right, I'm going to turn my page over in just a second. All right, I'll wait. I'm in no hurry. I'm here till 3 o'clock today. Maybe just 2:40.
I got it.
Do you have to stay after
I'm supposed to, my contractual hours are from 7:10 to 2:40. But I'm usually here by 7. So. And I usually stay well past 2:40. Depends on the days. No.
What?
Well, on Wednesdays I do tutoring in the media center, so I do get paid to stay to 3 on Wednesdays. So, sort of. All right, so this is letter B. This is example 2, letter B. This one, put on your thinking caps. We have the 6th root of 8x times the cube root of 2x. This is big boy, big girl math. Yes. I hit a monster this morning, and I think I'm starting to tweak. So.
I have Vital, but
I'm good, thanks. I don't have cramps. I'm good, thanks. Thank you, I'm good, thanks. All right, ladies and gentlemen, I think I said before to multiply or divide, you must have the same index. Do we have the same index?
No. Is that the answer?
No. So what we need to do is we cannot simplify radicals. We cannot multiply radicals, but what we can do is turn it into an exponential fraction.
no.
I know, I told you were going to love this. So remember, this is your denominator, this is your numerator. So we can actually rewrite this as 8 to the 1/6 x to the 1/6 times, all right, 2 to the 1/3
Oh, okay.
to the 1/3. All right, but here's the issue. In order to multiply these, we need the same base. Do we have the same base?
So now we have to do
You're close. Kind of. You're not exactly correct, but you're not exactly wrong. Can I write 2 as a... Oh, man, I hate when I do that. Can I write 8 as a base of 2? Yes, because 2 times 2 is 4, times 2 is 8. So 2 cubed is the same as 8. Yes? But what we need to do now is we're going to be raised to the 1/6
Oh my god.
times, I'm just going to line up our numbers and letters.
Wait.
All right?
Can we put the 1/3 in parentheses too?
You can, but you don't have to. All right, so what I did is I rewrote 8 so it has a base of 2. 2 times 2 is 4, times 2 is 8. So this is the same as 8, and then we had our 1/6. This is a number outside of a parenthesis on an exponent. So do I add or multiply? I multiply. So this is really the same as 2 to the 3/6. What? Archimedes.
He's done.
I just made that up. I don't have any idea.
Oh.
Oh, I'm sure he's well dead.
Oh, yeah, Archimedes? Ancient Greek. He's done. There's an Archimedes. See,
There's an Archimedes death rate. Yeah. All right, so now we have the same base. So what do we do to the exponents?
Wait.
Nope.
Oh, I have a question.
2 and 2, aren't those the same?
I have a question.
Oh.
Yes, Kyla.
Okay. Are you writing the x to the 1/6 and the x to the 1/3 with the 2 and the 1/3, or is it just like...
They're two separate things right now. We have numbers and we have variables. They're the same but different. All right, Liam, what was your question? All right, so now since we have... Now that we have the same base, how do we multiply exponents? We don't actually multiply, we add them. So we need to add 3/6 plus 1/3. So I'm just going to go over on the side here. 3/6 plus 1/3. In order to add fractions, I need a common. So what should I use?
PEMDAS.
I should use 6. So I multiplied the bottom by 2, so if I do it to the bottom, I must do it to the top. 1 times 2 is 2. 3 plus 2 is 6. So now our answer is 2 to the 5 sixths. So now, where you have the same base, what do we do to the exponents? Same thing. 1/6 plus 1/3. We need a common, which I would use 6. I multiply the denominator by 2, so if I do it to the bottom, I do it to the top. 1 plus 2 is 3. I know this is advanced math. Try and keep up. No, because the correct mathematical thing is, what form was it in when we saw the problem to begin with? It was a radical, correct? Is that what you said? So we should leave it as a radical. So in order to do that, we need to leave our index as a 6. So 6 is our index. It's the 6th root of 2 to the 5th, x to the 3. Now, is 2 to the 5th good math grammar? No. So what is 2 times 2 times 2 times 2 times 2?
Too much.
32. That right there is your final answer. And that makes my brain hurt.
Can we not do this again?
I just want to
No. Jail. Prison.
All right, we have one more example left, and we're done for today.
No.
It's easier than what we just did.
Yes.
I think. All right, great.
So when it's solved, it's also.
Yes, Kyla. All right, last problem for today. Then you have a brief assignment. Okay, you have a big assignment.
No assignment.
Next week, not next period. All right. But this might be on it, so it could be in your best interest to do it.
No.
All right, we have the cube root. So, cube root of x to the 4, y squared over 125x. Yes, this is evil.
Math is evil.
This is like the Dr. Evil. Dr. Evil pork chop. No. Mr. Dr. Evil pork chop. Yes. From Woody and Buzz. Toy Story. I think it's in part 2.
Where Dr. Evil pork chops, okay?
Yeah, Mr. Dr. Evil pork chop. At the beginning when Andy's playing with the toys.
Beyond us, your SAT doesn't. So you, your SAT does not.
All right, can we finish this and then you can do your homework and talk about that? All right, so if we look at the top, what do we have on top? X to the 4th, so we have 4 of them, correct? How many does it take to get out? So one set of x gets out, one does not. Why? Because this is a cube root? Oh, okay. All right, good. So I'm going to go like this. We know that 1 got out. We have an x that got out. So I'm going to put it right there. We know we have a fraction. And this x that's left over, was it on top or bottom of my fraction? Top, so it stays on the top. All right, next we have 125. I'm going to write 125. And I personally would use 5 and 25.
Wait, where did we get one? Oh,
Right there. All right, and then for 25, I would do 5 and 5. We're looking for cube roots, which is 3, so these 3 get out. So the 5 gets out. But What does this? But it's on the bottom of the fraction, so it gets out, but it goes underneath. It goes underneath our radical. It's underneath our radical. Sorry. Actually, I made a mistake. I feel stupid now.
Oh, does it still make sense, Kate?
No. This is what I did wrong. Is we had 4 on top, right? And then we had 1 on bottom. So what should have happened to this one and this one? They canceled out. And then it just left 3, and then what happened to the 3? The 3 got out. I hate when I make stupid mistakes.
We have right out.
I know. I just don't like making mistakes like that. And then the y squared. Does the y squared get out? So it stays there. So the y squared is the only thing left inside of the radical. The x got out and the 5 got out.
I get how it got out.
Because it's the cube root.
Yeah,
Since we have
because we had a fraction, right?
And then how can you tell that it's out?
Because it's not under the radical. Like, see how this was a big radical and it was under? All right, ladies and gentlemen.